Good morning, everyone. How's everyone doing? Good, great. I'm Sandy. I work as a technical lead at Databricks. I've been in Databricks for around 7 months now. Prior to this, I was a principal architect for analytics at Amazon Web Services, primarily working with software and SaaS companies. In Databricks, I also cover financial services. I have been in this space transforming data and AI and ML projects for customers for 18 years now. In the past 10 years, primary responsibility has been connecting business vision to technical implementation. And you know how that goes with AI, right? So the past 3 years have been crazy, to be honest. You have got leadership teams asking for output from AI. They want to see value from AI. And then you have got the engineering team who have no playbook on how generative AI works, right? There is no success story. Everyone is trying to stitch things together, figure things out. I've been in that place. I've been working with customers, trying to take shiny AI demos to production, and I have learned some lessons. So this talk is about sharing those lessons with you. I've come up with a framework that we are seeing taking shape in organizations, especially taking AI from pilots, POCs, to production. And this is what I want to share. Before I start, I wanted to check how many of you are trying AI or running an AI project in your organization? Okay, great. And how many of them are successfully deployed in production, running without any issues, and you know that there are no issues? Okay. That was an easy question for me, because I know that no one's going to raise their hands, right? But this is the idea. Let me start by 3 examples, right? These are examples with customers that I've worked with. The first one is about a SaaS company. When I was in AWS, I was working with a SaaS company. Generative AI was pretty new. Everyone was saying, AI, we need to do something with AI. So we went and started building something. When they went and tried to sell this AI feature on top of their existing product to an enterprise customer, it failed to clear procurement checks, right? The procurement team were asking questions around, where is the audit trail? What happens if this fails in production? What happens if your AI feature fails at midnight? Who's accountable? Have you got the support in place? Would our employees be responsible for it? And et cetera, right? The right answers were not in place, so the project did not go ahead. The second story is about a retail banking chatbot, right? We all have good experience with talking to chatbots, right? After every 2 questions, we said, please pass me to a human. And this is what happens with chatbots, right? With this retail banking chatbot, once they deployed it in production, they were tracking usage. They were tracking, accuracy metrics and all of those stuff. And they all looked really good on the dashboard. But they were getting customer complaints. They're seeing a lot of customers were asking their cases or their questions to be transferred to a human, which did not solve the purpose of having a chatbot in the first place. When they looked into the issues, we found out that the AI, although the technical accuracy metrics and everything were fine, it was silently failing. It was confidently giving the wrong answer to users, right? And the third story is about an AI agent. It was a customer who built an internal support AI agent, and it would read support tickets and historical issues that were raised and all of those stuff and give customers a solution to their issues. It sent an email to an internal customer team, and the email was completely wrong in terms of resolving the issues and stuff like that. When they started investigating it, they did not have the right answer on why AI did that. What are the decisions that AI made? Because they were not saving the decision traces. They were not collecting the audit trail, if you like. So the summary of these stories is that the examples that I described, nowhere did I mention that they were using the wrong model. They were using an incapable LLM. The models are fine. They're pretty good in the shape they are, especially today, compared to 3 years ago. But the problem lies, what I call in the rest of the 95% of the system. right? And that's where we need to think about the decisions that we make. So this is what happens usually, right? And I think organizations have matured a bit now, but especially it was true in the past couple of years. You come up with an idea, let's do AI on this particular use case. We all start thinking about, okay, shall we use GPT? Shall we use Claude? Which model of Claude shall we use? I have been in debates around these topics, right? We start thinking about the model first. Then we start thinking about building a demo, because executives say, we need to do something with AI, and you're thinking about, okay, let's do something, build some demo and show it to the org. Or we all have been running hackathons, right? And then someone will come up with a good idea in a hackathon. They will build the demo. They will go and show it to leadership. Leadership will get impressed. Some of these projects will get signed off. And then reality hits. They never ask the business what they want, right? The first crack when you move from demos to production shows up when there is no alignment on what success really means for the business. Because usually the demos are built by engineering teams, right? And oftentimes, engineers, although they're great in technical capabilities, if they're not working with the right business people, the domain experts, especially in AI, things don't match up well. Things don't align. So that's the first crack. The second crack happens when you hit production reality of the data, right? In demos, it's a control environment. You define the data sets. You choose the data sets that you want to work with. In production, the truth is totally different. So that's where the second crack happens. The third crack happens with governance. So thinking about audit trails, observability, who is accountable, what is the standard operating procedure when AI fails in production for a particular thing? They don't exist, and no one thought about them before building a demo, right? So what happens is you build this demo, you spend a lot of time around creating an architecture and building this solution. And then you start thinking about all of these decisions that needed to be thought about in the beginning. Because what you're doing now is 4, 5, 6, 7, as you make these decisions, you have to retrofit all the work that you have done in running a pilot or creating a demo. And that's why in my lessons with working with these customers, I think that we need to kind of reverse the decision-making sequence here. It's nothing new here, right? So what we're doing here is we're bringing some of the decisions that organizations usually make later in the chain to the start, right? So we usually start with define what success means. Not in terms of technical accuracy or AI performance, latency, etc. In terms of what outcome does business need from this implementation. The second decision we need to make around is building evals. And when I talk about evals are basically, think about them as test harnesses. So if you build an AI, you want AI to make some decisions. Before AI makes those decisions, you have to build a sort of test case of decisions that humans make today and how they make those decisions. What are the right decisions? What are the wrong decisions? What are the edge cases? Once you build that test case, you can run your AI tests or quality, AI outputs against these data sets to test the quality and improve the quality of AI. Right? So you need this eval data sets and the eval harness, as we call it, to make sure that AI aligns with the success metrics that you have defined in the beginning. Right? So that needs to happen before you think about the architecture, how the architecture will look like. The third is start with the simplest architecture. I often see, I land up in conversation with customers and they start talking about fine-tuning a model. Right? I'm not saying that fine-tuning a model is not the right use case not a right solution for certain use cases, but most use cases don't need fine-tuning. Fine-tuning is a complex architecture. It has got a lot of investment to be made upfront. There are simpler architecture that you can start with. Right? So that's another decision, like how can you build an experimentation pipeline where you can build these things in iteration, start simple, and then get sophisticated as you build the muscle of how AI is working in your organization. Once you have this in place, then you think about what happens when it goes to production, what happens when it fails, what are our fallback strategies? If AI fails, does it just tell the customer a random thing? or what that message should be, right? If it fails to make a certain decision, should it be passed to a human? Should it retry for 3 times? What is that strategy around every AI decision? That needs to happen. Then, once you have these things in place, you have made all of these decisions, then start building. Because all of these decisions, step 1, 2, 3, 4, feed into your architecture decisions. Simple thing is, like, for example, if you want to use RAG or fine-tuning or prompt engineering, there are different decisions that you need to make in terms of success metrics, governance, security, et cetera, all of them feed into that decision-making criteria. And then, only then, you go and think about models. Because there is no right model, right? Some models are good in certain use cases, and some models are better in other use cases. But with every model change and upgrade, this strategy changes as well. So you have to ground and test these LLMs models on the eval dataset that you have run. So once you have created that eval dataset, you run multiple models and see which performs better on that dataset, on your business dataset, not standard benchmarks, datasets that are from your organization, right? So these decisions, the choosing of model, the selecting of model should come at the end, because a lot of other prereqs need to be met before you go to that position. And that's why I call this approach reverse strategy, right? To be honest, this should be the strategy, but I haven't seen it while working with customers when AI was here, so I just said, okay, let's reverse the decisions, right? But if you look at it, this is how actually a project should be run, right? This is nothing new. Like, it's just, with the AI pressure and hype, we forgot how to build projects sometimes, right? We just start with the model and the demo and all of those stuff. When I talk about reverse strategy framework in different meetings, sometimes I get some objections and some follow-up questions. And so I wanted to align, before we dive deeper, I wanted to align on what it is and what it is not, right? So I'm not suggesting it is for you to avoid building quickly. In fact, I want teams to start building, iterating, experimenting, learning, and refining at the start. But those few steps need to happen first before you start building these solutions. I'm not anti-LLM or anti-tooling. Obviously, it cannot be true. I mean, if you're building AI systems, generative AI systems today, you have to use these LLMs. I use AI tools myself, so it's nothing like that. It's not a governance bureaucracy. It's just you need to achieve a minimum governance level when especially thinking about moving to production. So it needs to happen, right? And this is not only for large enterprises, right? This can be followed by any small startup, a small team, just experimenting with AI to make a production-grade system. So it applies to all kinds of organization. All right, now what I'm going to do is the 5 steps that I talked about, I call them reversal steps, right? So R1 to R5. I'll describe them a bit for you in terms of what it looks like when you start building AI, right? So the first one is start with the moment of decision. What does that mean? I mean, if you think about building an AI use case in your organization, it's a workflow, right? It's a business process that you're trying to map, and not every step of the process will be done by an LLM, right? So you have to decide which part of the process is handled by a human, which part of the process is handled by an LLM, which part of the process is handled by deterministic code, old school traditional software stuff that we are doing, right? Let's take an example, a very simple example. Let's say we are trying to build an AI-assisted code review agent, right? What does that mean? It means you need to have an agent that will review the code that the developers write. So like a senior developer, right, or senior engineer who would review code written by developers. Now, if you wanted to use AI in that workflow, so this is how the process would look like. First, there will be a pull request that someone will create to merge the pull request to the main branch. That pull request will be reviewed. So you can bring in an AI assistant to review that pull request. So the AI assistant will go and retrieve context. That's where AI comes in, not in creating the pull request. That's already handled automatically, right, through GitHub Actions or some of the other stuff available in the market. So retrieve context. LLM goes, and retrieves the context, understands the code. Then it reasons and classifies. So what does that mean? So the LLM understands the code. Then it will say, OK, these are the places where I see security vulnerabilities in the code. These are the places which don't look right. Now, if the LLM does that, you have to answer questions like who assesses them, who makes sure that what the LLM is saying is correct, right? And who will judge that whether it's correct. That's where the eval data sets come in, right? So you would have good examples of good code in your organization that have been cleared by senior developers before, by humans, create that data set and have this AI learn from that, right? Have this model learn from those test cases, and then align AI outputs like that. So this is how you think about building evals. The fourth step is generating output. So once it has done the review, it will generate some output. It will give some guidance to the senior engineer, what needs to be sorted out, what needs to be corrected, etc. And once it does that, then it passes over to the senior engineer. This is where human in the loop comes in, right? So they will review it manually and then execute it, as in merge the pull request to the main branch. Now you might ask the question that if a senior developer needs to be involved in every AI review, then where is the productivity, right? This is where you need to ask questions like what happens when AI is wrong. Why? Because once you judge the AI alignment and once you have things in place, like a procedure in place that a set of actions that you can take when AI goes wrong, a fallback strategy, that's when you start measuring how a senior developer's time is saved for the organization. For example, the AI can actually be very good in some boilerplate stuff. Like, for example, some of the security gates in coding are very similar across all organizations. And AI can be really good in easily identifying vulnerabilities in them. So it reduces the senior developer's time for code reviews, but it should also correctly output all of those code reviews. So what decision does AI improve? How can you judge whether AI is right or wrong? And what happens when AI is wrong? These are the three questions you need to answer in the reversal once phase. So I was talking about building evals as a harness, right? This information I took out from OpenAI's blog on evals. They released it, I think, beginning of this year or end of last year. It's a really good blog. You should read it. What it basically says is when we build evals, I have myself seen, and it's a common observation, a lot of these evals are based on what we call vibe-based evals. Like you would say, you look at the test case, you look at the AI output, and you look at how humans would solve that problem. And you say, yeah, AI answer looks legit, AI response looks good, and you go by that vibe to check the test cases, right? But what we want to do here is identify the right metrics of right steps, right? So with retrieval, when you say, okay, did we fetch the right context, you have to have precision and recall metrics in place to measure them, because otherwise it can be grounded in nothing, right? So the answer can be fluent, it might look legit, but it is not grounded on the data that you use in your organization. The same happens with generation. So in generation, you have to measure task success rates, right? And you have to identify the right metrics for your business case. And if you don't do that, then the AI might output the task in correct tone, but it might be silently giving the wrong answer or confidently giving the wrong answer to users. This is what happened in the second story that I was talking about earlier. The fourth is agent. So when agents come into the picture, agents not only run LLMs, they are responsible for calling tools, so like querying a database or writing into a database. They are responsible for calling, getting into loop or calling another agent or doing recursive tries. So let's say an agent tries something and it fails. It would go and try it again. Maybe you can configure like 3 retries before it goes to human, things like that, right? It calls APIs. So you have to make sure that all the decisions and all the connections that an agent make, all the calls that an agent make, they are traced and they are they're measured with the right metrics, right? So tool success, tool calls, are they calling in the right sequence, and all of these things. There are toolings available in the market now to do this automatically, right? So it's not like you have to build everything from scratch. And the last but not the least is the business value, right? Have you defined the right success metrics that align with the evals? For example, if you're building a code review workflow, is it actually reducing the senior developer's time in reviewing code? Is it accurate in reviewing code? These are the things you need to measure. Once you have done reversal 2, then comes selecting the simplest architecture. And this is how I see it works, right, in most organizations. You map it against risk and workflow variability. Variability just means how much does the next output, how much does the next input depends on the last output, right? So as I said, it's a workflow. The subsequent step will depend on the output from the last step. And how variable is that, right? If there is high variability, there is higher risk that AI will fail in implementing those steps. So the way I see is once you map it against risk and workflow variability, you can start with simple architectures like prompt applications. So just prompt-based applications, one-shot reasoning, few-shot reasoning, prompt engineering the application. Cheapest, quickest to start with, and quickest to start experimenting with, at least like in pilots and POCs. And that's just for low-risk applications, low variability. If you move up, let's say high risk, your data is sensitive. You want the AI to be grounded in your business data for your use cases. You think about implementing RAG architectures, retrieval augmented generation, right? Where you use the LLM's general knowledge grounded on your business data. And then you think about certain security parameters and guardrails that you need to implement in that architecture. But it's even simpler than going into multi-agent architecture in the beginning, right? Yes, multi-agent architecture is necessary. It will be helpful in your business use cases when there are like workflows like that. But you have to build the muscle of working with one agent and seeing what happens when an agent runs in production, what are the other decisions that you need to make. Only then you can go to multiple agents and start stitching them together. Because once you go to multiple agents, you are actually increasing the complexity exponentially. Every agent in interaction is a coordination problem, right? That connection might fail. What happens when it fails? An agent might pass the wrong information to another agent, and that agent might think this is the right information and do something that is wrong for the business, right? So all of these complexities come in. The best model that I see that works is a sweet spot in production workloads where there is high risk and high variability is deterministic workflows. What do I mean by that? Use LLMs where it's really safe to use them and do a lot of deterministic coding. So use 80% of the workflow as deterministic as you can, and then 20% of it just where LLMs can add real value in the business workflow. That goes back to the moment of decision reversal, right? That's where you need to sit with your product teams, with your domain expert, other teams to decide where will AI provide undifferentiated advantage for your workflow. Only then add it there, right? I'm not saying that other architectures are not good. This is the most advanced architecture that works in production, and you can start thinking about it. I've done a talk on AI engineers. Shameless plug. This one got good reviews, so I wanted to share. I talk about multi-agent workflows, why single-agent workflow is just a feature, and multi-agent workflow is a distributed systems problem. So if you are a technical person, want to understand how these things work, what are the pitfalls and what are the challenges that we see in organizations, you can look into it. All right. The reversal 4 is governance and design fallback. And this is really important. We talk about when agents use data, have you got contracts in place, right? What should be the structure of the data? What schema? What is the meaning of that data? Like, what happens what is the freshness requirement? So if the agent goes and queries data, how fresh should the data be? Should it be fresh as soon as like the last minute, or should it be from the previous day? You have to set up these contracts because as humans, when we access data and data is old, we can forgive. But agents will never forgive, right? They will just go, read the old data, and confidently tell the wrong answer to the customer. So you have to have these contracts in place so that the agents can go and read the contract and understand what it needs from the data and then retrieve that, right? That needs to be in place. Audit trail, this is not even a nice to have. This is a must have. You go to regulators, if you need to run AI, especially in Europe, in production, you need audit trails. You need to trace everything that the AI does. Every call that it makes to the LLM, every response the LLM gives it, every tool call that it does, every message that it passes to another agent, everything needs to be traced. And to be honest, when I look at this tracing data, I mean, you need a separate data strategy for managing that tracing data itself, right? Luckily, we have tools, like even in Databricks, we have got MLflow, which centralizes all of the tracing data in one place. We show you all the graphs and stuff like that, so it becomes easier to manage the data. But this is really important, thinking about audit trails. PII, privacy gates, classifying the data, what's PII, how should an agent read the PII, should it actually read the PII? Have you got security controls in place to make sure agent A, which is supposed to use PII, and agent B, which is not, they don't mix context in between when they pass message to each other? You see how complicated it gets, right? And these are the decisions you need to make in the governance and fallback strategies. Permission scopes, it's kind of related to what I already said. Who's permitted to look at what? How does the agent respect permissions already applied? Are the agents actually mixing context between each other? So we call this context poisoning. Like, one agent mixes context with another, and it might pass a PI information to another agent, which it is not supposed to look at, right? Things like that. And then the compliance path. So you have regulations, EU AI Act, industry compliance, security compliance, everything else. Whatever you are building, are you clearing the compliance path yourself, or you build everything and then go to the compliance and regulator and they say nothing's working, like nothing matches the compliance rules. So that means you have to go back and do the rework. So think about it, right? What compliance you need to clear? Are you actually hitting those rules? And the last one is value first. And this is what happens when I go and work with teams. Most of us still measure the traditional metrics, even when we're using LLMs, right? So usage metrics. You can have highly active users, right? But that doesn't mean that those users are getting the right value from the AI. And then you've got like sessions per week, feature click rate, time in feature, etc. These are the traditional. If you're from product or you're a developer, you know that we already measured these metrics. These are deterministic metrics, easy to measure, we can do it. But with AI, you have to measure outcomes. And AI running successfully doesn't mean it is successful, because the answer might not be helpful to the user, right? So accuracy, usage rates, task completion rates might look green on your dashboard, but user satisfaction might not be green. That is what you need to measure. That's what you need to, that's where the task completion rate come in case. Like, did they do what they came to do in terms of the users of the business, right? Could they achieve what they wanted to achieve from AI? Decision quality. Did AI actually improve the decision quality of my organization when I build AI for a certain purpose? Did it actually shorten the process? Did it save time, improve productivity, etc.? However you measure for that use case, again, because you have defined the success metrics upfront, you can do it now, right? And then, what is the human override rate? Like, how many times does a human still need to go and override AI decisions? If it is too many times, then it's better a human does it, right? There's no point of using AI. So you have to measure these metrics on a regular basis. It's not like just a one-time thing, right? It's a living system. You have to measure them on a regular basis. This is about thinking. It's changing the mindset of how you measure metrics with generative AI applications from the traditional applications and software that we have built so far. So all reversals together, just to summarize on the reversals, R1, workflow decisions, where AI makes decision, where human makes decision, when AI passes over to human, which workflow decision adds most value, right, if you add AI to it. Build evals, test cases, run your AI against these test cases, make sure they're aligned to what you want for your business. Simplest architecture first. Don't go with fine-tuning a model when you don't need to, right? Think about how you can start simple and build the muscle, iterate, and then improve it. Fallback and trust, right? If AI fails, what happens? In production, AI fails at midnight. Who gets the call first? Who is paged? What action do they take? Who should they contact, right? Otherwise, this is not going to work in production, right? Every AI output that is not valuable to the customer should be treated as an outage in your application. It's very easy to forget that because the application is still running. But if the AI output is not actually valuable, then it's an outage for your application. So these are not like, these reversals are not 5 separate things. You can see that they tie to each other. You have to think about them before we go start building your application. So once you start building this, reversals, this is how the production stack looks like, right? So, and all of these decisions that we have made kind of stick to each of these layers. So I want you to look at the right column, like what happens when these things are not in place. If you don't make the right workflow decision, where AI makes the decision, where human makes the decision, all of these things, AI just feels bolt-on. Like it feels like, oh, you have just added AI for the sake of adding AI, not for the sake of solving a problem. Second is the application layer. The hard failures reach users first, right? And with AI, it's very easy to erode user trust. AI gives one wrong answer to the user, that's it. You will find it's really difficult for them to come back and use their application again. I've seen that happen, even in internal. Like a lot of organizations start using internal experimentation, give AI solution to their internal teams to work with, and AI doesn't perform well, and those users never come back. So it's a graph like this. Like there's initial excitement, everyone goes and uses their AI, and then gradually it drops because it's not helpful. So that's something they need to think about. Retrieval memory tools, agents call everything they can, and whenever they call an API, they use memory, they use tools, etc. You need to make sure whether it's making the right decision, whether it is calling the wrong tool, whether it is deleting 400 production databases that Replit did once, right? So you have to track these things. Model gateway, the models you are calling, which models you are calling. You will not be, usually, I have seen organizations do not just use one model, right? There will be multiple models that you will be using for multiple use cases, for multiple services. Which models are you calling? How many tokens? What is the cost? You have to track all of these things. Otherwise, it's not going to work in production. It will blow up, right? Suddenly, you wake up in the morning and there is a, I don't know, $10,000 bill, right? Guardrails. Again, I talked about compliance failure. You need to think about security guardrails. You have to think about whether your AI is telling something wrong to the customer. So you put guardrails in there, right? You have to put guardrails to protect against prompt injection. So there are people who will try to break your system using clever prompts. So you have to have guardrails to protect against them. Observability, self-explanatory. Like you need to be able to observe every decision that AI makes, right? And you need to have a strategy for it. There are tools available in the market. You just need to make sure which is the right for you and how you do that. There are also open source tools available, right? Human fallback. This is the most important thing that I see. And a lot of organizations spend a lot of time in deciding when should AI pass over to a human, right? What is that threshold value? Is it like 80%? Is it 75? Is it 85? No one knows. Like no one has any idea. And this is where testing against eval dataset comes in the scene. Because what you're trying to do is mapping what humans do today that AI will do tomorrow, and align them as much as you can through this testing and through this eval harness. And that's why it's so important. One thing I want to remind you, AI is a living system in your organization. It's not like one thing that you have done and put to production and forget about it. You have to continuously collect feedback from users, from the feedback that you can gather from AI itself, like tracing and observability and everything, put them together. Detect what went wrong, diagnose why they went wrong, and then improve continuously. Right? This is a continuous improvement process. Remember, you're not maintaining a feature. This is an operating system once you deploy in production, and treat it like that. So this is a takeaway for you. You can run this. This is a very high-level thing. You can run this in your current program. Set of questions, right? I have marked them as red, amber, green based on what I usually see in organizations on the 5 reversals. Moment of decision, I usually see, because now we have matured a bit with generative AI, everyone kind of understands, right? Like, okay, we have to map out the workflow and we have to see where AI fits in this workflow, right? Because AI is not going to do everything. So I think that's why I see most organizations are leveling up now, like they understand this piece. Eval harness is the most underrated implementation that I see with technical teams. Yeah, some might do with 20 test cases or 50 test cases, but that's not enough, to be honest. Like, you have to continuously grow your eval data set and run eval pipelines automatically. Not only while developing these solutions, but also in production, in live monitoring, right? And that is where concepts like LLMs, judges, and all of those come in. Architecture fit, yeah, people understand prompt, RAG, fine-tuning, and all of these things now. We have matured, but I still see a lot of folks start with the complex architecture first, rather than trying out the simple one. Fallback and governance, I see this missed in every organization. And it's missed not because it is like no one understands about them. People understand, but there is no proper framework on tracing the AI decisions to where the governance decisions and fallback strategies should be made. So that's another thing to take care of. And then business value. Is a business value metric defined? I don't want to hear AI accuracy metrics, latency, performance, and all those things. They are essential. They have to be there. But we want to see, does it actually help my customer, right? Does it actually reduce my developers' time in doing code reviews? Does it actually improve our spend or our revenue, right? So these are things that we need to think about. So what does it mean for different personas or different people interacting with AI projects or AI initiatives in the organization? If you're a product leader, reversal 1 is your area. You have to do the R1 workflow mapping. This is your zone. You have to think about what's possible, what decision does AI improve, and who judges when the decision is wrong. You have to think about it. If you're an engineering leader, you have to think about AI quality, like uptime, as I mentioned. AI quality is, if it is not good, it is basically your application is not running well. It's not running, it's down, right? So it needs to be, you have to treat it like uptime. So AI quality monitoring, evals, and all of these things come under engineering remit, right? Architecture selection, driven by eval results, come under this remit. If you're an executive, stop asking, are we doing AI? Because this is table stakes now. I'm sure pretty much every org is trying out AI in some shape or form. You think about the reversals that I talked about and where you need to make the decision by the red, amber, green metrics, right? You look at them and say, okay, where do I need to make my next investment? Do we need to improve our evals data set? Do we need to improve our governance and fallback strategies? And this is where you start making investments. You have to separate usage value from reporting. Like I talked about the traditional metrics and what metrics does AI need. You have to think about how to map them for your business, for your organization. Because high usage might mean repeated failure, right? So with AI especially. So you have to think about these things. So 3 principles to summarize everything that you can take away. Don't start with the model. Start with the moment of decision. Start with where AI should be making the decisions in that workflow. Remember that production AI is a living system, is an operating system. It's not just a feature launch that you are doing on top of your product. It has to be evolvable. It has to be quality monitored in live environments. And then you have to prove the path to trust before scaling the path to intelligence. What does that mean? It means that if users don't trust, they're not going to use it anyway. So you have to make it trustable. Not only by saying that we are doing the AI gives the right answer, you have to provide the explainability behind it. Why AI made a decision? What steps did it take to arrive to this decision, et cetera, et cetera. I've got some resources on this link, some examples for you, like how to set up tracing, how to assess your production readiness with some of these questions that you can answer. And then I've got a test case template on how to design eval data sets. You can take that one as well. I do a bunch of videos on YouTube explain all of these things. So if you search my name or search AI in production on YouTube, you will get some of my videos. You can connect with me on LinkedIn. Or I have got a weekly newsletter where I share these learnings that I learned from my day-to-day work. Right. So I started with the question that how many of your AI projects are in production? And I think only one or no one raised their hands. Now I want to, when you leave this session, I want you to think, which reversal did you miss? Or did you miss everything? With that, thank you very much.